Hi everyone. I'd like to introduce our new approach, a novel implicit field representation designed for capturing multi-person interactions in 3D spaces. Our method aims to accurately reconstruct the 3D geometries of multiple people interacting closely using multi-view images. In previous works on multi-person 3D reconstruction, several methods have relied on the SMPL model, which represents humans as unclothed figures. This approach fails to capture fine-grained details like clothing and hairstyles. To overcome this limitation, methods such as MPSD have used implicit representations to reconstruct more detailed human figures. However, these methods focus on reconstructing individuals that are far apart from each other. In scenarios involving close interactions, methods like deep multicap require multiple optimization steps for each individual instance, using the SMPL as an initial estimate. Because these methods rely on accurate initial SMPL predictions for segmentation and localization, the process becomes computationally intensive and less efficient as the number of interacting individuals increases. To tackle these challenges, we propose a novel approach that simultaneously estimates geometry, identity, and contact fields to represent multi-person interactions, without relying on an explicit model like SMPL. Our method distinguishes each person in 3D space by estimating occupancy and ID fields, and models their interactions by estimating contact fields based on these. This enables us to handle complex interactions between individuals while preserving the spatial information of each person. Furthermore, developing methods capable of accurately reconstructing close human interactions is hindered by data scarcity. So, we created a synthetic dataset for multi-person interactions that includes scenarios involving 2, 3, and 4 individuals. Our dataset includes a greater diversity of characters, such as elderly people and children, and captures complex group dynamics in the scene. Here's a sample video from our proposed dataset. We incorporate multiple types of motions for each participant, enriching the dataset with a diverse set of dynamic interactions. Now, let me explain our model. From the multi-view images and normal maps, we extract local, pixel-aligned features by projecting each 3D query point onto multi-view image planes. We then fuse these features using a transformer encoder and predict occupancy values with an MLP to determine if points are inside the object surface. For the ID field, we borrow concepts from the scene representation transformer to capture global scene context and handle occlusions due to close interactions. Using images, normal maps, ray directions, and camera position information as input, we obtain a set latent scene representation with global context information. We combine this scene representation with our local features to extract global features that merge local and global scene information. We use this global feature to assign a continuous ID value to each point, distinguishing individual objects in close proximity. Finally, we estimate the contact regions on a 3D grid where different instances are in close contact. This contact field is estimated by computing the standard deviation of predicted ID values within a local neighborhood. We identify contact points where the standard deviation exceeds a threshold, indicating interactions or uncertainties due to occlusions. This is our results on Hi4D, a benchmark datasets. This is our result on our proposed dataset SynMPI. Here's our ablation results on the architecture. You can see that the performance is better when using SRT. Here's our supplementary video. From the input multi-view videos, we estimate the interaction geometry. Our method predicts the geometry field and ID field simultaneously. From these, we estimates the contact field. By doing so, we're able to model complex interactions between individuals in a unified way. Thank you for watching the video. If you're interested in learning more about our work, please refer to the main paper and visit the poster session at the main conference.